welcome again. This is yet another Cantico Boring show, and I don't know what is the episode number, because it got so boring I forgot. But today, I actually have another interesting topic for you about Blazor and server-side databases, and how do we actually store data in there. But first of all, just like last time, there is a GoToMeeting you can connect to. The link is on Twitch profile, so feel free to go in there. Maybe just shoot me a message here so that I know you're there. I don't watch it all the time, and I'll be working on the next screen. And today, actually, because all the time I forget what I wanna say on the Twitch, so today I just printed it out. I have everything in front of me, so I can make sure that I say all the things that I want and not have the stream last for 2 hours and more. So first of all, the picture on the desktop, that's actually from my last visit to Bahamas. So this is not a stock photo. I heard one comment about that. This is really my picture, and I really like doing these sessions because I've never seen my desktop so clean as it is right now. But let me fix that with Visual Studio. I'll actually move the window here. Now I'm again using a preview version of Visual Studio because that's needed for Blazor. And I'll actually start on a clean slate, and I'll show you what the project is about. So the episodes in the past that I used to do, it was the same project as it is right here, but I actually redid the whole thing because the basic project that I created on Blazor was only client-side, and I really wanted to have, or really wanted to leverage all the powers of Blazor, including the server side. So what I did is I actually re-implemented the site according to Timewarp sample. Not sure if you guys know about that one. Let me actually bring it up on the screen. Just open here a new window. So if you Google for Blazor Timewarp, you'll find one. I think it's this one. So here are the instructions. This is just how to install it, but I think there's gonna be a better link somewhere. Maybe this one. Right, so there is the installation, there is the usage. What this project actually does is it will give you all the projects in the project structure. As you can see here, WebDual is actually my name of the project. And it gives you actually 4 projects of tests and 3 projects of the actual implementation. Now I'm gonna go through each of them individually in a moment. But just so you know why I did that is that this project, when you run it, it actually runs first the Blazor server side. So the client, that was one of the biggest problems in the past that you saw in this show, that whenever you wanted to load the page, you waited quite a long time until all the JavaScript files used by Blazor were downloaded to your station. And only after that, the website started doing things. So the Blazor server side actually mitigates that problem because until those files are downloaded to your computer, Blazor actually handles the presentation server side. So when I run this site, you'll see that the page appears immediately, and over time it actually switches to the client implementation. I'm going to show that in a moment, but just so you know why I re-implemented that. And this project template also includes WebAPI ready projects. So that's another thing I wanted to do, because I wanted to have control over what is getting served from the server and what is going to be client side. Because not all the functionalities can work client side, like authentication, like database access and things like that. Because on the client side, the users see the whole code. They can adjust the code, they can do whatever they want. So for that reason, some part needs to be handled on the server. if you remember, last time I told you that, or the project is actually still based on the map and zones for residential parking. And I updated the front end a bit. So this is how the new front end is going to look like. This is actually the settings page. But apart from the front end refresh that I took from one of the templates lying around on the internet, apart from actually nicer UI, I also wanted to add some functionality, like seeing the list of cars. So if you have multiple cars, you could add them here. And the possibility of actually defining which zones the car is registered for. So there are multiple zones in the city of Brno, and depending on where you live, you can park with your car in that specific zone. And that, of course, means you can park in additional zones around it under some conditions. So that's the reason why it's possible to add another car and define what is the permitted zone for that car. In terms of the cloud storage, I think nothing changed there from the past. So just a reminder, let me open the project, just a second. I'll make sure I choose the right project to show you. Okay, it requires me to log in again. Okay, slowly coming up. I'll just switch to the next project and we should be good to go. Okay, there we go. So from the last time, from the last episode of this show, what we actually did is we changed the name of the product. So there was a rebranding. So the product is now called Kentico Content. That's the biggest change. Otherwise, the project did not change at all. The data here are still the same. We can take a look here as well on the areas. And of course, the UI changed a bit, so it's much more straightforward now than it used to be. But otherwise, let's take a look at areas. In terms of areas, nothing really changed. I'm not sure. Yeah. The custom element is not going to work right now because I'm hosting that locally. So let me see if I can try to switch the running site in IIS. That should help. So the last month we actually had a Kentico Connection conference, which is the reason why my IIS is configured in a wrong way, or in a different way. Let's not call that a wrong. And I don't remember what was the site. Okay, I'll try the default website. Let's see if that's gonna help. So I don't really remember where I put the custom elements. Yeah, this is still not right. Okay, never mind. If you want to take a look at how the data are stored within content, within the system, check out one of my other videos. It should be there. It should be on YouTube. So feel free to take a look at that. Because there should be, instead of the did not connect potential security issue error here, there should be a map, and the zone should be here. In background, it actually stores a list of a JSON list of coordinates, which define each and every single area. And last time we actually had a problem with performance a bit because there was too many points. I think it's actually a few thousand points for each zone, so it took quite some time to see. Or to find out if a point on a map is actually within a specific zone or not. So I've took a look at that as well, but let me get to that a bit later. So first of all, let me show you the parts of this solution, because this might be a bit more complicated than it used to be before. And I'll start with WebDual client. So again, WebDual is my name of the project. Probably not the best one, but it's the one that I chose at the start, so now I have to live with it. So here the structure looks the same way as with the Blazor website in the past. So I still have components, I still have pages here, I still have a startup class here that is used to register all my services that will be later injected. And I still have the services here, there's the implementation of them. I still use the content coming from Mechanical content. Now what's a bit different is that previously I used to have all the functionality in pages. Now when you look at map page, for example, this used to be quite content heavy in the past. Right now it contains only one component called map. So I just moved the functionality into components. The reason is it's easier and more straightforward to see the implementation of components and to let components actually talk to each other than to have all the functionality in the page. It's pretty much similar to the web forms. The way how we used to have it in the past with web forms and with pages and code behinds was also better to just have user controls than to have all the functionality in pages. So here you see that the component only contains one thing, that's a route, which doesn't even need to be here. I could just put it here. Oh, it's actually here as well. So the backend file doesn't even need to be there. So that's for the pages. You see I have a map page here, I have index page here, which contains only the header. And I also have here a settings page, which contains car settings component. So you see everything is encapsulated in components. And the components here is just a one component for location. This is actually a special case that is only used to show whether the client, whether the site is running on server or on client. So this component doesn't have anything to do with any kind of features, so that's why it's in the root. But every other functionality is within features. In 90% of the cases and in the structure, I'm just following whatever the Timewarp template suggests, and because that was built by more experienced people than I am, then I chose to obey that. If you have any comments on that, just feel free to let me know on Twitter or send me an email. I'm happy to learn, but that's what I did so far. And in terms of features, I can actually explain how that works on the map example. So it's based on the feature folders. I don't know if you heard about those in MVC. It's one of the ways how you can build functionalities in MVC so that you don't have a controllers, views, and models separated based on the type of the code file, but you separate them based on the features. So here you see that under features I have one feature called map, and that feature contains actions, components, helpers, and contains a state class. Now, actions in terms of mapping or in terms of displaying a map on the page, actions could be to check a location, because if you remember from the last time, there were actions happening whenever you clicked on the map. So the map would change its location, change its center, and that location, that center would be checked against all the zones, and it would tell you what kind of zone that is. And of course, the map is coming from a third party, so it needs some kind of initialization, so that's why there is an init action as well. And in terms of components, there is just one component called map, and there is one helper. I'm gonna get to that a bit later. So that's basically how it works. Let's take a look at the component first, actually, or let's run it first, so you can see what I'm talking about. Now the build is gonna take a little bit longer than last time, but once the browser comes up, you'll see that it's quite fast. Okay, so we're still compiling. Okay, so the Blazor project was compiled. Now we're waiting for the server. And there we go. Okay, sometimes this happens to me, that Firefox just forgets where it's supposed to go. Okay, let's open the console, see what's going on. Okay, the website's running. So why am I not seeing anything? Maybe it's because I opened IIS, but now I'm getting title here. Sorry. So you see, right now I'm running on server. Let's take a look at the map. That's the functionality I created in the last few episodes. So once we get there, we should see the map here, and I don't really see it, and it seems like it's a CSS issue. Maybe I broke something here, sorry for that. Let me take a look. Yeah, so the map container is here. And the map has 0 height, which is obviously wrong. Let's see if this is gonna help. Nope, still there is a problem here somewhere. Let's refresh the page. I think I'm gonna have to change the styles here. So I've been playing around with Flexbox, which seems to have been a mistake. So I think this is about a flex direction. This is still 0. Okay. Let me check the styles for a bit. So I'll just check the Visual Studio again. And the styles are in www.root CSS site CSS, so we should see everything here. And I have a lot of stuff for component, but there is no stuff for the actual map, which is probably going to be an issue. Because I've been working with CSS for the past few days, and it seems I accidentally removed the part for map. So let me see if I can take it from the older implementation. So this is the older implementation. I'm just gonna try to take that from here. So I'm looking for the map. Where is my map? Maybe it's in a separate CSS. Yeah, there it is. So this is what I want. So let me stop this for a second. I'll just put this here. Come on. Okay, for some reason I'm getting 0 bytes from IS Express. But we'll see. It's doing things. Maybe it just takes a bit longer. But I'm not on a battery, so the performance should be good. Oh, here we go. So let's go to map and see if the map is actually gonna show now. Okay. So the map did not get initialized. Let's check if, yeah, so the map element is good now. But we still don't see the map. Let me see if we have actually the scripts correct here. But we do. Okay, there is some issue here, but never mind. There's probably something that I broke when I was working on the settings. So I'll just try it once again to refresh the page. If it doesn't work, I'm just gonna switch to settings because that's the part that's interesting for today for the server side. So if this is not gonna work, then I'm just gonna skip it. Yeah, seems to not show me the map. Okay, so I'll just switch back to settings. Oh, it's doing something now, but oh, here we go. So it just took longer, and it required actually to run on client. So there is probably something wrong on the server that it probably does not render the map correctly. And it seems that my computer is having performance issues, but you see that when I click through on the map, it should be changing the current position here, and it also shows me the intersecting area. You see it's quite quick, and it correctly shows me the right area here. So the performance problem that occurred the last time, I hope that I solved it. So see, this works quite nicely. And based on the intersecting area, the next plan that I have is to actually combine the area codename and the area restrictions with the car that is registered on settings, right? So that's my original plan. So right now I'm able to know based on the location where you are in which area, and now is the time to actually let you add the cars and the rest. So for that I'll switch to settings. You see that currently I have 3 cars inserted, and I can add another car or I can edit some of these cars, but I'll show you how that works in a moment. What I wanted to show you in terms of the project structure is how the map actually works. So I'll just stop the project for now, and I want to show you the component here that's called map. And the map actually contains the element for displaying the actual map on the side. It has one info box, that's the one showing the current position and the area you are in. And in the backend, or in the code behind, you see that there are a few things that are worth mentioning. These are the properties that I'm using on the component. So you see it's the same way how I did it in the past. So I'm using the current position and intersecting area. And I'm loading them from a map state. So the current position is a property that I'm using on the component. And here I'm actually saying that that property will be filled by a map state, by a class that's called map state. And in the map state, you see this is actually a simple class that is used to store some kind of context. In my case, it stores the current position, it stores which area is intersecting, it stores the restrictions on that area, and some other things. It also stores the information if that map was already initialized, because if it hasn't been initialized, I will need to run the initialization logic. That's the third-party JavaScript code, right? Some of these things I will probably be removing and putting them into their specific components, but it was the first draft, so please bear with me. But you see that these properties are actually mapped only here to the map state. So the map state is actually one level higher than the components and their properties. This component actually checks if is this one. If the map state was initialized, so this only occurs at the very start of the application, and if it wasn't initialized, it actually calls the location helper to watch location. I'm gonna get into that in a second, but it also calls a mediator that sends a new init map action. Mediator is some kind of a middleware that handles all your actions regardless of if it's running on server or on client. So you don't care where that runs, you just care about the action. And the init map action does not have any additional parameters. It only triggers the JavaScript interrupt operation. So in here, when we look at map actions and init, there is an init map handler. The init map action is just a simple class that does not have any other functionality. The init map handler actually contains a JS runtime. This is constructed by Blazor, so I don't really need to care about where do these all come from. But the only thing I need to care about is how to handle that action. And you see that the only thing this does is it calls JS runtime and invoke async the function map init. And this function is included via a static JavaScript file. Here in map.js, there's a function called map init. So this is how it works. This is how the JavaScript function gets triggered, and it actually sets the center of the map and does all the other things it needs. It also registers .NET invoke method async call for set location method on the Blazor side. So whenever you click on the map, this function will be called. Right? This is for checking the location. And of course, to enable something like this, like the checking of location, we can go one step back. And before the actual initialization, I call a watch location helper class and helper method. If we go here, you'll find that this is actually a static class with a static watch location method. And that method, the only thing it does is it assigns a watch callback. So this is a function. This watch callback is a function that I receive as a parameter and is invocable from here. And this code, this JS invocable set location, is actually the code that is invoked whenever you click on the map somewhere. So in the map, when you click on the surface, the map actually calls this function that checks the coordinates and invokes a method called WebDualClient setLocation. Where did I lose that? Here it is. So WebDualClient setLocation, which is this exact method that is marked with the JS invocable attribute. And once that is invoked, it actually takes these three parameters, that's the coordinates, and with the coordinates it calls the callback. So the callback is just a pointer back to the map. back to this component, and you see that here on the component it's set to onset location. So this method will be actually, as a result, this method will be called for every single click on the map. And you see I'm calling map state current position. So I'm setting the position as the current location, and I'm sending another action that's used to check the location. Now once that happens, we call another handler. Very similar to init map handler. Again, we only care about the handle method here. And what I'm doing here is just checking the area, checking what kind of, or which area is actually the one that I'm looking for, which is the area that contains the point. And if that actually exists, I set that as an intersecting area. If that doesn't exist, that's gonna remain null. Right, so that's the only thing this does. In here, I did the performance improvements that I needed to do in from the last time. So now it's working well. So I just optimized the checking function for the point. And right now it actually again returns one area and sets that as an intersecting area. Now once that happens, this is all actually happening within the map state. So you see the map state is an partial class, internal partial class, that contains this handler. So this handler can directly change the map state. So I'm just changing the intersecting area to null, because with every check that will be different. And when I set that, the map state is different. And when we go back here to the previous method, it also has a state has changed. Now state has changed actually forces the component to re-render. So once this action is handled and the area is found and the map state is changed, I'm also changing the state of that particular component. So as a result, you saw on the map that the location was changed and also the intersecting area was updated. So that's just an explanation of how the WebAPI client works. And the next thing, let me check the list. Yeah. So the next thing is the WebDual API. Now, let me actually put up my favorite tool, which is MS Paint. I'm gonna do a bit of drawing, but I actually prefer Epic Pen to do the drawing. Oops, it seems I don't have it installed, so I'll just have to stick with MS Paint. Okay, that works. So right now we talked about the Blazor client. Let's call this one Blazor client. Users are interacting with the client. So let's draw a user here. And this is the client project. That's the one we see here. That's the one that I explained right now. But there's also an API project and there is also a server project. So let's draw them here. Let's do the server. So this is the Blazor server. Doesn't have to be actually Blazor. This is just a simple .NET Core project. So it's a .NET Core server. And in the middle, there is, how is it called? API, I think. Yeah, WebDual API. So the way how this works and how it was designed by the Timewarp project is that in here, within the API project, there are definitions of the data contract. So this contains the definition of a car that I will be storing later. It also needs to contain all the definitions of all the data you need to transfer between client and server. And the client does not only mean client side, but this can also be Blazor running on server. So let me make this a bit less confusing. Let's call this one really only server, and this is Blazor server. So these two parts are to some extent interchangeable, so they can run on server or on client, but this one defines the data contract between Blazor side and the server backend. So if we take a look at the project again, here under features, let's take a look at the car store. That's the most interesting thing here. And the car data object. So you see that the class for a car contains an ID, license plate, node, and zone permit. These 4 properties are defined in the API project. And this part, the Blazor part, is actually responsible of building an instance of that class, filling that with data. So let's think about a use case that the user wants to add a new car, right? He interacts with Blazor, and Blazor actually builds that instance of that class with data. And it also gives the information where that should go. So there is a route information where that controller that will be handling this request actually sits. While on the server side, this actually contains all the functionality. So there is a database here. We store the data, we read the data, and so on. So this actually understands the data it gets, and it contains all the logic here that we need to do in order to process the data. So the process is that the Blazor creates the instance. It goes to a specific URL defined by the API project. It gets processed here, and Blazor receives a response. This communication happens via HTTP client. So this communication is really between a client and server, or between a server and server. It really works that way, that this is actually a standalone part. So when we take a look at the project here, let's start with the get list. So the get list functionality actually gets only the list of all cars. And let's take a look at the request first. So in the request, you see that there is nothing else but the route definition. So this is just a definition of data for the server side, and for Blazor to know where it should send its request to. So it's this part, the black part about the route. And when the route gets triggered, or when that route gets hit, it's actually work of the server, or it's work to do for the server that then has to have an appropriate or respective controller to handle that request. So that's essentially how it works. You see that this request does not have anything else in it, because for getting the list of all cars, we potentially will need some kind of identifier or identifier from the user to know which cars to get. But right now, for the simplicity of things, I just work without any authentication. So the request does not have any additional parameters. And the response, when we look at the response, the only thing it contains is the list of cars. So list of the car data object of cars. Now let's take a look at the server. How does the server handle this? So we look at the features, and we're looking at get list features. So you see I'm trying to stick with the same structure. So features, cars store, get list, and it's right here. Get cars controller. And the controller only needs to be registered for the route. Otherwise, all the work happens in the handler. So this is the route. You see it's getting the route from the get cars list request. So that's what I showed you like a minute ago. And the handler is used to actually handle the request. So You see I'm getting the request here, and I'm doing some kind of entity framework magic that I will get to in a moment. But this is the place where everything happens, and when I'm ready with the logic, I can build a response and send that response back to the client. And the client actually receives it. So let me show you one component that actually uses this particular request, which would be under components and cars list. So the cars list actually contains a call for the list of all cars. You see that here. So when the component gets initialized, there is an override for uninitialized async in the backend or in the code behind of the cars list component. And if that state, you see there is a cars state, but it's the same as the map state. So it also contains a property for initialization. And if that list is not, or if that state is not initialized, it actually sends a new fetch cars action. And the fetch cars action, we can look at it here under actions. The fetch cars action actually creates a request. I didn't rename this one, but it should be fetch cars request, and invokes the post.json async of HTTP client and really tries to get that request to the route that was specified. So the request gets to the route. This logic waits for the response, and the response gets inserted into an observable collection of cars. And that observable collection is again part of the cars state. You see we're again within the cars state in a partial class. So when we go here, you see there is an observable collection of cars. Observable collection because there might be some components that will need to be reinitialized when that collection changes. So that's essentially how it all works together. But now let's get into something more interesting. So when we run the site, I want to show you how we can actually add a car, because right now getting a list of cars from the server is quite easy and simple. But I want to show you how we can actually insert a car or update a car, and that's a functionality I have yet to implement. So we might enjoy some fun while doing that. Okay, let me check what's slowing down my computer. I'll do that while this loads. Okay, it seems it's actually Streamlabs, which is the software that I'm using to stream. So I'm probably not gonna kill that one. But it's up here. So let's go to settings. And here there is actually one thing that you might notice, that right now I'm running on server, but when the page loads, and as the files actually make their way through to the client, you'll see that it switches from server to client and reinitializes the page, which means I'm losing the data that I fetched while I was on server. So let's just give it a second. Oh, come on, go to the settings page. So what's happening is that I'm rendering the page of settings through the server. So the server actually gets all the data from the database, from Kentico content, and displays me the page. But once the files are actually downloaded to client, and I as a client am ready to take over from server and handle the rendering of the page myself, at that point, I actually get the reinitialization of the page. So that means the client needs to do the same requests to the database and to Kentico content to get the same data the server did. And I'm not getting to that page. So I still have not found a way how to mitigate that. I'll probably try to work around with the Web API and see how that works. Okay, let me see what I can do with the performance here, because I don't seem to be getting my page. Okay, I'm gonna kill GoToMeeting. If someone wants to talk to me, please send me a message on Twitter. But I'll kill that for now. That will give me a few percents of the server computation power. Okay, this is better. So you see that I'm running on server now, and I got all the data, and it's gonna take a few moments to see that this page will actually get reinitialized when the client gets all the data. See, now all the data disappeared, and I'm waiting right now for the list of data from the database. But more importantly, the add car component contains a list of all zones, and the zones coming from critical content currently come with all the coordinates. So it's few thousands of coordinates per each zone. So in total, it adds up to almost 1 megabyte of data. So it's a lot of data coming through. So that's the reason why it's so slow. I'll probably have to work on that to get the performance to the next level. But you see here that I can add a car or I can update the car here. Now adding of cars works. So let's put here Twitch test. And let's add there zone 120. You see that there is a debugging output. So the component is actually getting the new data. When I click save, it actually adds the car here. And it will also be in the database. Now let me show you that. In the management studio here. So when I execute this query, you see that the car, this is actually zone. Let me put here another query. Cars. Okay, so you see in cars, I now have here the Twitch test, which is also via ID connected with the respective zone. And this was FB95, which is this one. That's the 120 zone. So this works well. Now let me show you how that is actually implemented. And once I do that, I will also need to implement the delete and edit, because that doesn't work right now. So the the settings component actually lives in the features, cars, components, and car settings. So let me show the front end first, actually. So first of all, there is a cars list component. That component only shows the cars, right? It contains here one for each of cars and contains some actions whenever you click on the update button or remove button. It doesn't do anything else. When you look here at the code behind, you see that it just fetches the cars if it wasn't initialized yet, and if the car state was already initialized, it actually only gets the cars from the state. So whenever I need to add a new car in the car settings, that's a different component, I just need to add that object to database, obviously, but for the sake of other components, I just need to add it to the car state observable collection. And it's gonna ensure that I see the car in the list as well. So this is the cars list, but in the car settings in the front end, apart from this component, you see that there is a component for adding cars or editing cars based on whether the new car is actually set or the new car ID. So in order to display this this form, there is a new car object. That's again car data object. Nothing really complicated. And based on the existence of ID, I distinguish between adding a new car or editing a car. But that's not the important part here. The important part is that whenever you click the save button, it calls a save car method. So there is no form anything, there is just a save car on click button. And that method, what it does is it actually again sends a new action called setCarAction and provides the data for it. So the new car is the model that whenever you type something in the form, it actually is stored via Blazor binding. It's stored in the new car model, and this action contains that model and is sent over to the handler. Let's take a look at that. So the setCar handler here again creates a request and provides the data to the request and waits for the response. So the response actually needs to come from the server side, and on the server side under setCar controller there is also a handler here, and that handler again does something with the database. So it inserts the car into the database, saves the change, and returns a response that does not contain any data because we already have the car in Blazor cars state because it was created by another component. But what happens here is I actually need to handle that on my own. So once that car is stored in the database, I do that here. So I add the car into the observable collection of cars. So I add it here. And I also call notify on insert. Now this is an action that I created on the car state. Let's take a look at that. You see that what the method does, it calls the invoke on event on insert. So as long as there is at least one listener that registered to this event, it's gonna on every insert it's gonna invoke that event. And what this does actually, so if you look at the on insert, there is one event handler that is created here on initialized async of the cars list component. So this component listens for all inserts and all collection changed events. Actually, this is for delete as well. And when that insert happens, this event is called, and this event handler will actually reinitialize the collection that's here in this component. So this component has its own list of cars. So what it does is it reinitializes that list from the car state, and it calls state has changed. So that will actually make Blazor reinitialize and re-render that component. And you saw that when I created a new car, it actually worked. So these are the steps needed to actually keep everything up to date. Now what I wanted to do here is I wanted to add another action for actually storing or for updating the cars. Sorry, not storing I already have, but for updating a car. And it's gonna be very similar to setting car. Actually, usually when I do something like this, I just use the same code and base the action in the end, if it's gonna be insert or update, base it only on the presence of ID. So let me do the same thing, and we start in the car setting component. So here you see that, or actually in the cars list. So you see that if there is a car in the list and I click on the edit button, it calls the edit car method here. And in the edit car, I'm just defining what kind of car I clicked on. So there has to be a way how the component can notify the parent component or any other component of some data that other components need. So in my case, when someone clicks on the edit button of the cars list, I need to tell other components that will actually render the edit form. I need to tell them what kind of data they are dealing with. That's exactly what's happening here. So the edit car method actually calls the car state edit car with an ID of the car. When we look there, you see it just selects that specific car from the list of cars, from the observable collection, and stores that in the selected car property here. And from here, the code is quite straightforward, I think. When we look at the car settings, the car settings, as I said before, is based on the new car model. And if that new car ID is empty, so in case there is that is a completely blank model, that will happen when you're inserting a new car. In that case, it's gonna render the insert new car header. And in other cases, when I select the car here, that's actually invoking this method as well. So yeah, there is one additional step. Sorry about that. I forgot about that. So here I'm defining the selected car. So the selected car property will be filled with the car that I'm about to update, and this state will actually invoke the onStartEdit event, just to let other components know that there is something happening with this car, and if they are interested in handling that event. Now the car settings component will actually be interested in that, which is why on initialization of that component, we're actually actively listening on that event. So car state onStartEdit will be handled with this event handler, and that event handler actually just copies the selected car from the car state to the new car model. So instead of providing a blank model for the insert car form, we have that model already filled with data. So when I go back here into the car settings, you see that I can now base all the decisions here on the existence of that ID of the new car model. So in that case, the editing will be yellow, the new car will be red, and I also update the wording a bit, show the license plate if that's a car to be edited, and everything else stays the same actually. There is a list of zones, there is a bound license plate model, or an input bound to model, and of course based on the existence of the ID, I would also have to change the save car method. So let's take a look at that. When I click on that, what's gonna happen here? So in here you see that I'm just creating a new action with that car. So I'm calling a setCar action with the model as a car. So from this code, from the point of view of this code, nothing really changes because the code will be the same for both actions. And we reset the object for a new car and say that the state has changed. So let's take a look now how that action actually handles it. So it creates a new setCar request with the car. Everything is so far everything is okay here because the ID will be propagated correctly, and it calls the action on the server. So let's take a look there in a second, because there is one thing that we need to solve, and it's this one. So car state cars add. Now this is only true for new cars. So I'm just gonna change this so that if action car ID is not GUID empty, and actually this is not true because the GUID should come from the response. So in order to have that list complete and to ensure that if I insert a car, I'm able to update it in the same application state, I also need that server to give me back the GUID of the car. So I'm just gonna change the setCar response, and I will probably need here, let's take a look here. I'll probably need here another property, just like I have the list of cars in the get cars list response. I'm gonna need the same in the setCar response. But it's not gonna be list, it's gonna be a GUID. Car ID. or just ID, it's fine. And of course I have to adjust the action on the server so it gives me the ID, but that's gonna be a quick operation in a second. So let's just assume that I got the ID back and get back to, okay, this is the response, get back to the handler. So here I'll probably need to have a helper property here saying that this is new car. So action car ID equals GUID empty. And in case that is new, actually I could also use that property or that condition here as well, because that will not be changed. So I can do this. And if that happened, I can call, I can add the car, and I can also notify on insert. If it's not empty, I'm gonna call car state notify on edit. In this case, I also need to adjust or update the car. So action.car.id will come from the response ID. And now everything should be fine, because now the car state is the same as the state of the database. So this should be good. And in case this happens, we'll just notify, and that's fine as well, I think. But what we will probably need is we're gonna need to update the car in the collection as well. So I'm just gonna remove that car from the list of cars. And that would be action car ID. What's wrong here? So removing, oh. So we're gonna have to do it this way. Because I no longer have a reference to the original object. Okay, we're gonna need another namespace here. Okay, we're removing that, and we're gonna add here action.car. So I'm just removing the old one and adding the edited one, and notify on edit. So this should be good. Now let's take a look at the server side. So on the server, maybe a quick intro into the how I set up the entity framework and the database. So I decided to use entity framework because it's the fastest and most straightforward way how to create the database access on a .NET Core app. So I just installed a few dependencies, mainly for the SQL server. So Microsoft.Entity Framework core.SQL server, to relational, to the package of tools, and the core package here. So those were the packages that I needed to install in order to have the entity framework there. And I also defined a few models. One model is for car, ID, license plate, node, and zone permit. So it looks pretty much the same way as the car data object. And the other one was for zone. So zone contains only ID and codename. It's not ideal because the codenames are already stored in canonical content. But I haven't really, it's the first draft, right? I haven't really worked on that. So I just created these two data objects. Now I did not want to use the data objects already created here, like the car data object here in the API project. The reason for that is that every layer, or at least the database layer, should have its own models. in case there need to be some changes or some adjustments that each layer may need. I find it a best practice to actually have these separated. And in the cars context, that's actually the DB context of Entity Framework. The only thing I did is I provided connection string to the right database and provided a DB set of the object that I want to store, which is the car. So this is the only thing I did. I then created a migration and updated the database with that migration. It's really easy. It's just the one command in the package manager console. Not sure if it's gonna actually be here. Yeah. So you just call add migration create cars db. In my case, it was create cars db. And once you create that migration, you just call update database and you're fine. So it's gonna create the database for you. This is the code first approach. You can also do the other way around to create the tables and then create the models, but this just seemed easier. Cool. So when that's done, you're free to use Entity Framework DB context anywhere you want. So that's what I did in the setCar handler. And you see that whenever there's a request for a setCar handler, I'm prepared to insert that car into database. So I'm using the new cars context in the using code block and creating a new car. So here you're probably gonna be better off with using mapping like an auto mapper. But again, just for the sake of this project or this example, I did it by hand, but in the future I see this as one of the first improvements that I would do. Just create a mapper for these models. And once the model is filled, I just add that into the cars DB set and save changes. So this is the Entity Framework code. And that's what I will need to change here. Because if I already have a car in there, I can't create a new one, but I have to rather update the car with the new data. So let's change that here. So if request car ID is not GUID empty, this means that the car already is in the system somewhere. So the car will be context cars single, and I'll find it based on ID. And if the request car does not have an ID, I'm just gonna create it. And here, of course, I need to update the values. So license plate would be request car license plate. Actually, what I can do is make it even easier for both cases. Or I think I need to actually, yeah. Is there an adder update? Probably not. So, okay, I'll just keep these as they are. So car license plate would be request car license plate. Note would be request car note. And zone permit. It's gonna be a bit more complicated because here this is a list of zones. So I'm just gonna omit that for this moment because that might take a bit longer to figure out. So I'll just do it this way for now. And once I updated that, I think I can just call car update, can't I? Okay, I'll just call cars update car. And save changes for both, that's fine. Set car response. Here we're probably gonna also need to assign the ID. We don't have a car. Yeah. So I'm not sure if this is actually gonna work. Oh, we'll see. Because we're in the using, I'm not sure if that's gonna, the car is gonna stay there, because we're in there, but we'll see. We'll see in a moment. But anyway, the data should be correctly updated, and we should get the ID back, hopefully. So this is how you adjust the server, and I think that's all. Let me check once again the car settings, if that will work well. And start edit. I think this is fine. This should be also fine. What I need to do here is I will also need to clear the selected car. So once we save the car, we're gonna clear the selected one. That should be fine. Or what we can actually do is do this. Cancel edit to save some code. Okay, and once this happens, let me check once again the notify on edit. The cars list should also react on edit, not only just on insert. So I'm just gonna fix that here. On edit. And I think I can use the same one on insert. So we're gonna reinitialize the cars list and say that the component state has changed. All right, let's see if this is buildable. Okay, so far so good. So now we're building client. Okay, 7 succeeded, so that sounds good. Let's take a look if that's gonna work as well. Okay, so right now we're on server. Let's go to settings. Okay, here we are. Now let me let's just give it a second to run it on client, so that, yeah, there we go. And another second to load all the data. There we go. So let's check. If I click on the edit button, it should show me the Twitch test here. That's fine. This is the license plate, or let's take this one, for example, right? So it actually changes the context of the edit dialog. If I click cancel, it should reset the form. So let's just put here another test. Okay, this works. We got the right zone here. We should already have that in database. So we got it here, and the Twitch test too. Now let's see if the edit is gonna work as well. So let's just edit this one. And save it. Okay, so this was updated. And let's check in the database. This was updated too, so it seems that the code is working. And of course, the zones will be a bit more complicated, but as the storage of zones is not ideal right now, I don't want to go too deep into that. As well as the names of zones are not displayed here. So these are the code names of all the zones, right? But I hope you understand the main principle. That I get everything in the database here, and right now when I go back into map, I should be able to put here a selector that will list all the cars for me, and based on the on the currently selected car, I can then say if that car can be parked on a specific spot on the map, or it shouldn't be there. But that's for another Twitch. So for today, I hope this was clear. If you have any questions, let me know. I'll make sure to check the Twitter and other channels as well. So if there is anything I can explain in greater detail to make it more understandable, let me know. Or if you have any suggestions and comments to my code, feel free to let me know. I'm just learning Blazor, so I'll be grateful for your comments. And thank you for watching today, and I'll see you next time, hopefully.